There's nothing better than working with a nice, tidy dataset, but more often than not, you're just not going to encounter data like that in the wild. Luckily, there are some really great tools out there to provide a ton of help in the data cleaning process. One tool that I recommend is the dplyr package for the R programming language, as you might have guessed from the title of this video. What follows is kind of a crash course on dplyr, which will hopefully be a good intro for newcomers and a quick reference for the more experienced. As a bit of a disclaimer, I'm assuming you already have some experience with programming and have R and dplyr installed. If you need help with either of these, I'll leave some resources down below. I'll also be including timestamps in case you'd like to skip around. So, the name dplyr is a mix of the words data frame and plyr, a fitting name since it's basically the Swiss Army knife of data manipulation in R, allowing you to handle virtually all of your data cleaning with it. It's a part of this thing called the tidyverse, which is a really useful set of R packages, introduced by Hadley Wickham and his team. They help with virtually all steps of the data science process, and they were specifically designed to work really well together. But for the purposes of this video, we're just focusing on dplyr. The 5 key functions of dplyr are filter, arrange, select, mutate, and summarize. Each of these 5 functions can also be used with a 6th function, group by, which allows you to perform them on groups instead of individual rows. More on that later. All of these functions have a similar structure where the first parameter is the data frame, and the second parameter describes what it is you'd like to do. It's worth noting that they do not modify the original data frame, and instead return a new data frame with the function performed, so be sure to store the results somewhere. With these 6 functions, you're pretty much set up to transform your data in any way you see fit. But let's break down these functions a little more and look at some examples. For demonstrative purposes, I'm going to be using the NYC Flights 13 dataset. Link in the description. Filter lets you filter rows based on a given condition. Like in this example, we are filtering the dataset for flights that occurred in November or December. Filter allows for the use of all of the following comparison operators, as well as all of the following logical operators. Take note that the logical AND uses a single ampersand, and the logical OR uses a single pipe, not double. I know that's gotten me more than once. Arrange lets you rearrange the rows in your dataset. In this example, we are ordering rows in ascending order based on the arrival delay. If we wanted descending order, we would simply use the descending function. We can also provide additional parameters, where each additional column is used to break ties when deciding the order. Sometimes you might find yourself working with a really wide dataset, one that has a ton of columns. Select is very useful in this case because it lets you select only the columns that you need. Here we are reducing the good old flights dataset to just be the dates of the flights. If you wanted to select a range of adjacent columns, you could use a colon, like so. Lastly, here are some functions that are pretty useful in conjunction with select. In the case where you'd like to create new columns based on transformations of existing ones, you'd use mutate. With this example, we are creating a new column that is the difference between the arrival delay and the departure delay, and we're calling it gain. There are a lot of functions that can be used with mutate. I'll show some of the most useful, but this is by no means exhaustive. Last but not least, we have summarize. What it does is summarize your data into a single row. In this case, we are summarizing our entire flights dataset to get the average departure delay. Take special note of the na.rm. Basically, this removes all of the na values before doing any summarizing. Because of the way na arithmetic works, we would end up with na as our final result if there was a single na value in the dataset. Now, on its own, summarize might not seem very useful, but a lot of the power in this function comes when you first group your data with group by. Here, we group the rows by date, and then we summarize by those groups. This ultimately gives us the average departure delay for each date. As you might expect, there are many useful functions you could use with summarize, but here are a few that are frequently used. As a final note, sometimes you may want to remove the grouping from your data, and this can be accomplished with the ungroup function. Before ending this video, I did want to talk about a really useful operator that comes with the tidyverse. This operator is the pipe. What it does is it takes the result of the left-hand side and uses that as the first parameter of the right-hand side. In this simple example, we take our dataset on the left and then use that in the filter function on the right. Here's the equivalent code without the pipe. Now, the real power of the pipe is that it allows us to create chains of dplyr operations. Here, we are taking the flights, grouping them by destination, summarizing to get counts, and then finally filtering to get counts greater than 20. If we were to do this without the pipe, it would look like this. Notice how the code with the pipe is much more readable and doesn't involve a series of intermediate data frames. Very cool. Hopefully it's easy to see now that with the use of these fundamental dplyr functions, you can accomplish some pretty complex results. Of course, there is a lot that I didn't touch upon in this video, functions like rename and transmute, but I think all of this is a great starting point. Feel free to let me know what you think in the comments. Thanks so much for watching.